Okay, let's take a look at the systems unit. More specifically, we're going to be solving quadratic linear systems. Linear means straight line, quadratic means curved, parabola, also circles are possible. So, this first question, number 19, which values of x are in the solution set of the following system of equations? We only need the x values here. Okay, you don't need the full ordered pair. So, because both of these equations are solved for y, our substitution step is very simple. Okay, the first one's already done for us. Solve for y for the linear equation. Next step, substitute it to quadratic. So we're going to take 3x minus 6 and we're going to plug it in for y right there. Okay, and that's how we get this. 3x minus 6 equals x squared minus x minus 6. And you would go through your regular steps, adding 6 to both sides, subtracting 3x. Those cancel out, we get 0 equals x squared minus 4x. This also cancels out, and we could factor here. There we go. And you go ahead and you solve, you get your solution set. Now I want to show you an alternative method using a calculator. So I went ahead and typed in both equations. We have 3x minus 6 and x squared minus x minus 6. So there we have it, y1 and y2. Let's graph it, take a look. So here we go. There's the linear equation and there's the quadratic, parabola and a line. There are 2 points of intersection, and the question was, what are the x values of it? So points of intersection are where basically where the equations are equal, or in other words, where the y values are equal. So let's go ahead and use the table feature. And let's take a look here. As you can see, both y values, y1 and y2, are both equal to 6, where x equals 4. And when we scroll down to x equals 0, y1 and y2 are both equal to negative 6. So the answer to this question is 0 and 4. These are both of the roots where these equations are equal. Okay, number 20, same type of problem, except the question is which ordered pair is in the solution set. So you need your xy coordinate. In other words, when you get your answer, when you get x, your roots, you want to plug it back in to find the y value that's associated with the x. So our first step would be to take our linear equation here and solve for y. Okay, 3y equals x. Divide both sides by 3, and y equals x over 3. So we can basically now do our substitution. So we want to take what y equals and plug it in for y. So there's y squared minus x squared plus 32 equals 0, and we plug in x over 3. Now when we square this, we end up with x squared over 9 minus x squared plus 32 equals 0. We're going to combine like terms, and I'll let you do the rest. Okay. Here's one tip for you. As you're working through here, you could also multiply everything by 9 just to get rid of this denominator. And once you get your root or roots, make sure you plug both of them back in to either equation. I think this one's easier. to find your y values. Number 21. Which ordered pair is a solution of the system of equations shown below? Pretty much the same type of question. Here's our linear equation. We're going to solve this for y. So we're going to have minus x, y equals 5 minus x. We're going to take this, 5 minus x, we're going to plug it in for y right there. Okay, so let's go ahead and rewrite this with 5 minus x substituted in for y. And let's clean this up. We can just combine like terms. 5 minus 3 is 2. So this really becomes 2 minus x. And this is x plus 3 squared. We're bringing this all down. We want to FOIL this term and FOIL this term. And you will end up with a quadratic. Solve for x, get your roots. And once again, since they want an ordered pair, you're going to have to substitute back into the linear equation to get your y value. Number 22. All right, same type of problem. They want us to solve this algebraically, so we're going to use substitution. So I've added x on both sides, so we have y equals x plus 5. We're going to take x plus 5. We're going to substitute it in wherever we see y in the other equation, the quadratic here. So now we can simply rewrite this quadratic equation, 17x plus x plus 5 plus 4. We can go through, we can combine like terms. As you can see, the negative 17x goes with the positive x, and the 5 and the 4 can combine, giving us 9. And once again, I'll let you finish this one. And because it doesn't specify whether it wants the ordered pairs or the roots, you always want to give as much as possible, but I think the roots will be just fine.